Alright, we live. Boys, girls, how we going? Happy Sunday. Got a shitload of repairs to get done before the usual crap of weekdays happens. So this is a Marshall Mode 4, supposedly 350 watt head. Zoom out there if I can. No, it's already all the way. It looks like a fire happened in wherever this was stored. I've got some other photos on the Facebook page, but everything was covered with a thick layer of black soot. It was really horrible. I've cleaned everything up as good as I can. There's a little bit of corrosion on the tops of some of the caps. That's not too bad there, but it probably shows worse there. Couldn't clean that off at all. So I just cleaned it as good as I can, and now I'm going to basically, well, I've troubleshot the amp and found what was wrong. It was two resistors in the power supply, and I've replaced them there and there. They're like filter, combined with the little capacitors down there, they form a filter to filter out any crap coming in the line, the power line. So that's those two there, 1, 2. They were open circuit and they'd overheated. You can see one of them's not too bad, but the other one, the colours are all different. The gold doesn't look shiny anymore, and they're just discoloured. One's fully open circuit, the other one's measuring like, I don't know, like 20k or something, but they're supposed to be 2.2 ohm. They look really underrated for all the crap that circuit's supplying. It's supplying like, what? We've got, let's have a look at this on the screen capture, if I can, if I remember how to do it. There we go. Alright, so here's the board. That there is the two resistors that were blown, R23 and R44. They go through a bridge rectifier there to change it to DC. Then it goes through one regulator, two more regulators. All these chips, that's all digital circuitry, probably for the switching. Let's check that you can see all that. Yeah, cool. And then you got a bunch of op amps that it's powering. So that basically is showing that it's going to all the rails. It's not showing the other pins of those particular chips, but it's just showing that it's supplying them. And then this thing, which is maybe IC11E, where's that? That's probably on the DSP board. Can't tell. But anyway, another chip probably draws a fair whack of current. And they're rated at 1 watt. Stock I don't understand that. That's going to be drawing more than 1 watt. And hence they've blown. So, yeah, I don't know what they were thinking there. So I'm putting like 2 watts back in. I think they're 2 watt. They're probably 3 watt actually, back in. They're fusible, so if anything goes wrong in any of these chips, they will act like little fuses on the secondary there, which is an added level of safety. So that's what I put back in. And there you go, that's the circuit, that's the power area. It's a bit hard to follow these modern schematics because you got connectors everywhere and you got to flick between pages back and forth, but as the amps become more and more complex, you really can't show everything on 1 or 2 pages. It's got to have separate modules, and each each module has its own schematic, and it shows them where they all plug in. So it's part of the preamp. There's switches and shit everywhere on this thing. It's super complicated. It's got a DSP chip for the reverb. Doesn't have a reverb tank. It's got digital reverb. That's just click out of the screen capture and back into that. Here we go. That's where they're getting the reverb from. That's a DSP chip. Texas Instruments there. That's probably memory. That's something else. That's an Atmel. So I guess that's the processor that's really controlling the DSP. So that's probably changing the programs and whatever. That's probably dealing with your interface on the front panel, and that's actually doing the processing that creates the reverb and the effects. It's got another chip down there which is probably a clock generator, and then there's your crystal where it would derive its signal clock. You got some 7/4 series logic down here, don't know, and you got two what look like possibly regulators there, probably to get a 3.3 rail happening for the computer, and all of that connects via this little pin thing here, which is actually pretty clean. I was worried all the connectors might be dirty, but it looks like, because it was smoke damage, it's really only gone where the airflow was, so it's settled on all the components, but it hasn't found its way right inside all the connectors. They're all pretty clean still, so that's lucky, otherwise it would have been a major job. Here's the amp modules. There's 4 modules on 2 heat sinks, so 2 of these. They've got a fan integrated, just cheapo computer fan. It's got sort of a custom mounting plate, which is probably Marshall's doing. This thing here, the actual fan is just this section here. That's the mounting plate. But there's not a lot to the modules. They're sort of standalone chips. So that's the TDA 7293, and there's 4 of them. So they're just probably generic class AB mono amplifiers. They might even be stereo and bridged up, but they're all running in tandem to supply supposedly 350 volts. I haven't looked at the data sheets yet, so I don't know if that's legit. It probably is. If you bridge all of these up, you probably get pretty close to that, but I can look that up. In the heatsink here, they're tunnels. You can see straight through them, and they've cut a segment out where the fan is, so the fan's forcing in the side of it, and then it's coming out both ends, and that mounts to the back of the chassis like that on those vents that look a bit too small for what they're trying to do. That one and that one. So that's another disadvantage with solid state amps. Anything high power is going to have to be fan forced. So it sucks all the dust in there and it deposits on everything. So you really got to take it apart and clean it every, I don't know, depending how much you use it, 3 to 6 months to be safe. And if it's in a dusty environment, probably more. Same with computers. People, no one really cleans their computer out, particularly laptops, because they're a pain in the ass to get into. So they all fail, especially where it's high humidity or high, you know, if you live near the beach and there's a lot of sea spray or something like that, that's real corrosive and it attacks the shit out of everything. Yeah, no one really maintains stuff anymore. It's probably part of the reason why stuff fails all the time, in addition to it being cheap. So anyway, that's the main board. That's got your power supply. It's an interesting circuit, actually. It's got a whole bunch of control circuitry on there. There's fucking diodes everywhere. It's got a ground lift circuit there, which is limited with diodes. So the ground is technically not connected to the chassis directly, but goes via those 2 diodes and that resistor. That's to float the ground, because it is capable of pretty high gain and it could amplify any ground loops pretty easily. So that's to try and mitigate that. That's cool. Yeah, you got that's supplying the main supply for the, they call it HT, but you know, it's a solid state amp, so it's like plus minus what, 32 volts from the tranny down here. That's supplying the main input for the power modules, the power amp modules. And here's your preamp supply. Now all of this is derived for all the control circuitry as well, and that's where our problem was. So although the power amp was firing up and the light was turning on, so I got the classic report of turns on, no sound. So it wasn't turning on at all. It's just that the light was turning on. Usually the light on the switch is directly connected to the main, so it'll turn on regardless of what's happening after it. So yeah, I thought the worst about this, but it looks like it might be recoverable. Just so many hours cleaning. I reckon I spent 3 hours just scrubbing the friggin' thing to get all that smoke residue off. This thing does have two 12AX7 preamp tubes. Not sure where exactly they sit in the scheme of things. Let's open up the schematic again and have a Gizio. Here we go. Alright. So let's have a look. It's all control stuff. Let's go at the start and have a look from the start. You'd imagine it would be somewhere near the input, but you know, maybe not. There's your tone control for one of the channels. It's all op amp. Keep going. No tubes there. No tubes there. Transistors, op amps, and logic. No tubes there. That's your amp module. Not a lot to it. 4 of them. Ah, there's the tubes. Go connected, blah blah blah. I don't know. So you got a FET there. It's probably doing some switching. Switching? No. That's the 12AX7 or CC83. It's actually pretty interesting how they've derived that high voltage from the low voltage supply. They've used basically created IC, fucking need another coffee. They've created AC off the existing DC rail, oscillated it, switched it back and forth with these two transistors, sent that AC up this diode ladder, which is a voltage multiplier. You look these up, they're actually pretty amazing how they work. They like switch the caps on, and then the caps end up in technically series, and it uses all those caps to discharge and then filters it with this cap. Because it happens at a reasonably high frequency, you don't need that big a cap because the ripple won't be massive. And it generates high voltage to power these, probably around the sort of 180, 200 volt mark, to get high tension on the tubes out of a low voltage supply. I've seen them used in pedals too. You've got to be pretty careful. You can drive them directly off a transformer, like a mains transformer, the low voltage one. But then your caps, filter caps, need to be somewhat bigger because you've got longer space between the peaks of the waveform that you've got to filter out. So I kind of like this little arrangement with an oscillator and a switching output stage, and yeah, you can actually see the diode bridge. It's I'll just go back to the camera. It's actually right there, and that's all your caps in the diode bridge. I shouldn't say bridge, diode ladder, I guess. And that's what's generating that high voltage. That little circuit there, this corner of the board, and one of those caps is probably a filter for it. There's probably there's a few filters in it. They're all rated 160 volts, so yeah, it probably is running a bit low. 12AX7s can max out around, well, generally they're about 180 volts in your traditional Fender type circuits after it's gone through the anode resistor. And here you can see where all the diodes are linked together in the ladder. And that generates your high voltage out of a low voltage supply. So pretty smart. Saves you another winding on the transformer, and it allows you to use the same transformer for different amps, and just by putting this board in you can introduce a couple of valve stages. So pretty smart the way they've done it. Don't mind that at all. Pretty crappy board, but hasn't failed yet. Had to clean all the crap out of the sockets. It wasn't too bad in the sockets, but just on the board. And yeah, a little bit of corrosion on the cap. So I'm hoping everything's going to be sweet and I don't have to go replacing a whole bunch of shit. I've told them it might be a little bit on the expensive side because I've fixed the initial problem, but I haven't fired it up to see if it's secondary stuff or weird noises or whatever. So that's something we'll have to suss out next. So join me as I put this crazy thing back together and try and figure out what goes where. Yay. Because you got nothing else to do on a Sunday. It's better than Netflix, this shit, eh? There's a switch. It's a bit squeezy down here. There's even a lot of rust on the transformer too, on the laminations there, which is pretty full on for an amp this age. I mean, the things have only been around for what, 10 years. She's had a hard life already, and they're not really built for a hard life anymore, not like older Marshalls. I mean, this thing's pretty well built. It's solid state, but it's got all the sort of touches that one of the high-end Marshalls has. They're all sort of the same shit these days, but it's not like one of the DSL 40 series, 40C or whatever they are, the Chinese made fucking things that are just brutal, horrible. Connect the mains inputs. I've marked them 32032. See 32032 on the tranny. And 19019, same as the tranny. Sweet as, bro. Alright, that's sort of sitting there. It's got these little steel post things. They sort of just expand over the board. Not real positive, but once the connectors are tightened up on the panel there, everything will hold in place. Good enough for Marshall. Now, I've got connectors bloody everywhere, and there's multiple places they could go. So I took some photos, instead of writing everything down and labelling it. I just went the cheater route. Took some photos of where everything was plugged in. So, as I go, I'll just have a quick look at the photos. That was there. Cool. That one's obviously there because it's the only one that size in that area. I started labelling them and it was just way too much work, so I just started taking photos. That one. over there. What's that one? Module goes on there. Be a bit gentle with these surface mount boards, that you don't bend them too much, especially with big chips like that. You bend them too much putting the standoffs through, and you could crack solder joints, because basically the chip doesn't bend, the board does bend, and these pins only have so much give. So be a bit gentle with them. Alright, what next? Just give that panel a bit of a clean up. Not putting it together permanently at the moment. I'm just getting it together to test it, make sure there's no other issues before I give it the full clean up. And once over and check everything. I couldn't even get it to start before, so if we can get it to start, we can check everything else is functioning right. Until you've got a heartbeat, you can't work on the fucking headache, can ya? Alright, so that one. 1, 2, 3, 4 goes there. And that one goes there. We've got this grey fucker. Where do you go? That one. From there. No matter how many photos I take, I never seem to take enough. There's always one thing that I've got to look at or try and find a schematic for. Taking photos is really important when you can't find fuck all info about the amp. Sometimes it's your saving grace before you take it apart. You just take a million photos. It's never enough though. You always miss some angle, or you can't see where something connected to something, and you got to actually use your brain, which sucks. Alright, the valve board went down here. Just left the screws in there so I didn't lose them. That's the first thing I took out. Got no drop frames today. I'm recording and streaming in high def. It probably doesn't look high def from your end because our internet's third world. But it's recording in high def, so I'll be able to put it on the YouTube. I'll be able to see some details. Like how manky this thing really is. Boom. I don't need that socket just yet. Might be taking it out again anyway. Alright. Now, we're connected to that board. Yeah. That's the little short one. That's that one. Okay, signal on the bottom, so it goes that way. Sweet. And this one, goes under there. Yep. Alright, so there's the two ones for the modules, because they sit there like that. And there's two others that disappear to the other two modules. And they go in one way. That didn't feel like it. Oh yeah. Didn't feel like a real positive action when it engaged. There we go. Dig out those screws. I'm gonna have to mount the modules back on there because there's nothing holding them there in place except those screws. That's the furthest one, because this one you can tell used to have a cable tie on it, so it would have just gone down there. This is all the clues you use. Half the time you don't need to write shit down when you take it apart just because you're used to seeing it. That's had a cable tie on it because it's got a big bend in it. So that was that one. Not that it matters because they're universal, but might as well put them back where they were, eh? Otherwise something will catch me out. Always does. Get the diagonal screws in there to start with. Makes for riveting viewing. Screwing screws in. Yeah, I've got to get through all these amp repairs. I like to do all the electronics in a batch and then do all the woodworky or, you know, guitar based stuff in a big batch. That way, partially because the guitar based stuff makes a bit of a mess. Wood chips, that kind of thing, and sanding, spray paint. I don't like to have electronics open on the bench while I'm doing that kind of gear. Also for ordering, so I try to get all the amps open on the bench all at once, or at least do them all in 1 or 2 days. Do the quotes, I mean, because then I need to order parts, and the parts, usually from overseas, will take about a week to get here. So I try to do the quotes as soon as I can, or at least estimates. I'm running out of time to do proper quotes, write them up and everything, and half the time if they don't go ahead, it's just a massive waste of time, so I don't make any friggin' money. So I kind of got to stop that and just give them an estimate, and if my pessimistic estimate is way outside their range, then I just won't look at the amp, because no one will be happy. I mean, people already come to me I mean, the customers are good, but I can understand they're not in the best state of mind when they bring me something, because it was working, now it's not, and now they've got to pay money to make it work again. So they're not really, it's not like you're getting a new device that you're excited about, like going to buy a new fucking iPhone or something. It's, their device was faithful, then failed, and now they've got to spend money to make it work again. So sometimes they're not willing to part with that money, which is fair enough. I want to give them a pessimistic estimate. If it's over that, then I sort of have to wear it. If it's under that, then happy days. If they're not happy with my pessimistic estimate, they don't get to see happy days. They just go elsewhere. I used to do really detailed quotes, type them up, took me half an hour, you know, look up the prices of the parts, really carefully put a margin on them so I'm not ripping anyone off, and, you know, it just takes forever. Don't have time for that shit anymore. People still want it, but I just have to give them an estimate. That's all I got time to do. Oh no, there's your problem. You got a message tube in a Marshall amp. As if Messer make tubes anyway. Fucking liars. They just tag them. There's probably Softec or something. Don't know who makes what at the moment. The other one's an Electro Harmonics. These are the ones I usually use. Might be switching to JJ's soon though, because I can buy them in bulk, direct. But yeah, Electro Harmonics are good. I suggest them. So, where are we? Oh, hello everyone. I've only just looked at the Facebook screen. Alright. Keep plugging this thing in. Got the fan supplies down here. They're probably in series, probably doesn't, parallel, probably doesn't matter which one I plug in where. But, yeah. Alrighty then. See if this thing blows up, eh? Let's double check my wiring. Yeah, it looks good. Just secure that switch a bit better. Put the tubes back in. Just check the heater supply of that. Those tubes. Crown. They're in. Huh. All four of them in series. Interesting. It goes to minus LT, which is low tension, which is what, 15 volt? No. It's going to be 24 volt in series. Let's go see what it's putting out, if it has a figure there. Oh, went past it. LT. Plus LT. Minus LT. Guess that's going to the fans. They're in. Oh, they're copping 12 volts each, so yeah, it'd be about 24 volts. Yeah, AC. Yeah, AC. Strange. Oh, hang on. All right. So let's gingerly fire this thing up, eh? I just want to check that there's no shorts on the secondary there. After I run over my multimeter lead. Let's have a look at the schematic again. DC. What am I talking about? Yeah, so the AC goes in there, it's bridge rectifier, so DC comes out the ends, out its ears. That's your plus, that's your minus. So it's 24 volts plus minus 12, I guess. Alright, I'll check from the output of that rag. So across C21 and C39, we'll see if there's a short. I should have done this before putting the board back together. C21, 39, that's it. Ah, this is fucking hopeless. Yeah. Alright. Got my long probes in there now. I'll just check the resistance across those caps. 4.7k. $5k. No short. I'm confident to plug that in now. I want you to start with a limiter in series first. In case something else is short in the power amp, but there's no blown fuses, so it's mainly just a paranoid thing. Now this is a solid state output stage, so I don't need a dummy load on there to power the thing up. We have fanage. Seems to be drawing a fair whack of current though. You can see that's the lamp. It should just give like a pulse and then die down. Let's isolate the secondaries. Just literally the only thing the power is going into is the primary of the transformer, and we'll see what it does. Interesting. That's not good. I think that transformer is fucked. It's running. But that's drawing way too much current for an isolated transformer. Like that's almost full on. That's fucked. Alright, so what caused that? it could be just moisture shorting turns internally. Just switch it off for a sec, just check it's not the switch causing it. So now it's not even going to the transformer. Nothing. Well, that fucking sucks, man. I don't even know where to get one of them, and it's probably going to be like at least $150. Alright, well I might high plot test that. So I get at the insulation tester, see what the fuck's going on. Man, I should have tested that before I cleaned the fucking thing up. Alright, so I get this scary bastard out. No, it's not, there's scarier ones, but this is goes up to 1,000 volts. There's some that go up to like 10,000. Probably should have got like a 2 or 5,000 volt one, but if something's drastically wrong, this will show it. Is that the one? これ4つ. Very good for you. See that? Warning. Voltage coming out of there, not going into there. So what it does is it pumps a super high voltage across these two leads. Oh, plug the wrong end in the wrong end. And sees if there's any leakage. You click that scary button. And that's when it pumps out the voltage. And you can see if there's leakage from winding to winding. It doesn't show you shorted turns, but it'll show you if it's melted through the insulation between two layers of winding. So click it up to 1,000 volts, push it in. So that's showing no leakage there. If I touch there, see it goes through the roof. Might zoom in a bit there. Alright, so because that winding goes between there, if I touch there, it's showing that there's a dead short there. If I go there, showing nothing, which is what you want. Go there, showing nothing, which again is what you want. But these primaries and secondaries would be pretty well isolated. There's probably a pretty heavy insulation layer between the two. These ones may not be that well insulated from each other. But, you know, so that's the same one there. Yeah, don't know. It's something's wrong. Could be shorted turns on the secondary. I better look up what one of these is worth if you can even get it, because that's almost like dead short across that. You can't test it with your multimeter because it'll show a short circuit anyway because it's DC. Just check the resistance between, see that there? There we go. Between the two halves of the windings. 1.2. 1.2, that's right. 0.3. 0.3, so that'd be a beefier winding because it's got more current. 0.3. The leads are probably 0.1. 0.2, 0.1, so there's a bit of an error happening there. They do look like they've gotten warm, but that could have been from the soldering. Sort of see a little bit discoloured around the base there. I just wonder what's caused that to go. I mean, let's see if we can get any signal out of it at all. I mean, you know, it's already fucked. Just check the rest of the amp. If it's providing enough power, and maybe check some rails before the fuse blows. That's the mains fuse down there. It's, just unplug that. It's rated at 230 volt. It should be time delay 4 amp. Let's see what. I've already checked this, but I'll just show you that you've got to check this. You check this. Bit corroded. T4E, 250 volt. So that fuse is correctly rated. But that fuse is after the secondary. Is it? No, it's before this. Yeah, it's on the primary. So if it was drawing excessive current, that should be blowing. Let's try it without the load limiter. See if we can make some smoke come out. Whoa. Well, that's really annoying. That's the fans going mental. Fuse didn't blow. Alright, let's plug the speaker in, see if we can get any signal. If there's heaps more wrong with this amp, it's probably not worth it. And these things aren't going for $1,000, but you know, that's probably pretty schmicko condition. They're going for $1,000. Let's turn everything down. There's nothing worse than blasting yourself with noise when you're trying to test something and you've already got a clenched arsehole. It's a good way to shit your pants. Even the knobs are feeling all chewy. The knobs. Some signal going in. It sounds horrible. And nothing. Oh, hang on, tune and mute. Oh yeah, there we go. Oh, she's chewy. Oh. Oh yeah. This thing is fucked. Everything's working. working. Man, those heaters are barely glowing. I guess better check the voltage across them too, but the fans are now calmed down. Probably just the bearings have settled down a bit. Trainie's not getting warm yet. Alright, looks like there's a fair bit more work required in this thing. Oh, listen to that. Fucking hell. If I turn that up a bit, every pot scratchy as fuck. It's weird, like some of them aren't. So, oh fuck. I mean, that could be DC across it if a coupling cap's fucked or something, but you generally don't find that in solid state gear because the voltages aren't as high and they don't break through, but who knows, I'll have to check that too. Turn that reverb down, it's just annoying. It sounds like the gain might be affecting a feedback loop. Have a look. Yeah, so 50k. That's one of the channel modules. So that part is really dirty, and because it's in the feedback loop, it's somewhat more dramatic that it's dirty. Okay. Awesome. Just check some voltages. There we got a ground. Really. One. So the plates of those 12AX7s are sitting at 70 volts, so yeah, not real high voltage. Starved plate, they call that condition. That's probably what it's designed to be, but yeah, she's not getting I wouldn't get the proper sound of a proper tube amp. Proper. Pin 495. It's running DC. Minus 12. 0. And pin 9. 6.5. So yeah, it's getting enough on the. It's getting DC heaters. 25. That's 12. Minus 18. yeah, so all the heaters are getting the right voltage. They're just, some valves, the heaters really poke out the end and you really see them glowing. Others you can barely see them glowing, but they're still glowing. They're just inside their little tube. Yeah, so I think it's going to be load test this tranny. See what's going on, why it's using so much current on just isolated power up. And then clean all these pots, see if I can get another one of them. I mean, it's working at the moment, so it's hard to justify, and it's not getting hot. I'll just check that I haven't done something stupid first and that everything's cool, and then load test it, I think. And we'll go from there. Load test it on the Variac with, I don't know, a 4 ohm load or 2 ohm load or something and see what happens. Yeah. So anyway, I might piss that one off for a minute and see what's next. We might do something easy for a bit. Just for a change. Well, you know, everything starts off easy, doesn't it? I'll just keep all these parts together. Piss this thing off.